This experiment is about linear thermal expansion. The objective is to determine the coefficient of linear expansion of metal rods. Materials used are the following: thermal expansion apparatus with the following parts: the metal tube, dial gauge that will show the amount of expansion of the metal rod, inlet for steam or inlet for the source of heat, outlet for steam, and terminal for the digital thermometer. We also use the digital thermometer to read the temperature of the metal rod, meter stick to measure the length, and the steam generator that will be the source of heat. Procedure: fill the steam generator with 2/3 water and bring it to a boil. Make sure that a rubber tubing is connected to the generator's outlet. Measure and record the initial length, or L sub O, of the metal tube in centimeter. Take note also of the material makeup of the tube. Carefully place and secure the metal tube in the expansion apparatus. Adjust the dial gauge by turning the outer ring until the zero mark coincides with the outer gauge pointer. Attach a digital thermometer to the terminal provided in the apparatus. Set the digital thermometer in Celsius scale. Read and record the initial temperature of the metal tube from the digital thermometer. Allow steam to enter the tube by inserting the rubber tubing to the steam inlet of the metal tube. When the metal becomes hot, the pointer of the dial gauge rotates counterclockwise, an indication of a thermal expansion for the tube. When thermal equilibrium is established, read and record the final temperature of the metal rod. Also, read and record the final reading of the dial gauge. Do the same procedure for the second metal. Measure and record the initial length of the metal tube in centimeter. Take note also of the material makeup of the tube. Carefully place and secure the metal tube in the expansion apparatus. Adjust the dial gauge by turning the outer ring until the zero mark coincides with the gauge pointer. Attach the digital thermometer to our apparatus. Get the initial temperature of the metal tube. For this case, this is 27 degrees Celsius. Allow steam to enter the metal tube by inserting the rubber tubing to the steam inlet of the metal tube. Observe the counterclockwise movement of the dial gauge pointer as the metal tube becomes hot. When thermal equilibrium is established, read and record the final reading of the dial gauge. And read and record the final temperature of the metal rod. You may now fill up data table 1 completely for the two metals, aluminum and copper. From the data obtained in data table 1, calculate the change in dial gauge reading, which is the final dial gauge reading minus initial dial gauge reading, the expansion of the metal tube, which is obtained by multiplying the change in dial gauge reading by 0.001 centimeter, the change in temperature, which is the final temperature minus initial temperature, and out of this, you can now compute for the alpha or the coefficient of linear expansion experimental value. And comparing the computed alpha experimentally to the alpha, which is the true value, to get the percentage error, and that is the percentage error is the absolute value of the true value minus the experimental value divided by the true value times 100. Complete the laboratory report by answering questions 1 to 5.